Hello, welcome to another session in mathematics. In this session, we'll be looking at logic. But before we continue, let us take a review of our previous lesson. Welcome back. In our lesson today, we'll be looking at tautology, contradiction, and chain rule of logic. Okay, so let us start with the word tautology and contradiction. When we talk of tautology, we are looking at a compound proposition whose the combination of values and its constituent statements are always true. He said when a compound proposition is always true for every combination of values of its constituent statements, then it is called tautology. Okay, when the values are always t, and t, then we say that tautology has taken what place. Okay, then on the other hand, when the proposition is always false, it is called a contradiction. When we have our final answer to be f, and f, then this is what we call what? Contradiction. It is contradiction when it is false throughout, and then it is tautology when it's true throughout. Okay, so bear these two things in mind as we go ahead. Let us take some examples. Construct the truth table to show that P implication negation of negation P is a tautology. Construct the truth tables to show that P implying negation of negation P is a tautology. How do we achieve this? Okay, solution. I hope you still remember all the laws of the connectives that I taught you in previous classes. So the first thing we need to do is to draw our P. Okay, we'll draw our P, and our P then will be truth and what? And false. Is that correct? Then we have the negation of P. For negation of P, T will become false, and false will become what? Truth. That's what negation is. Is that correct? Then we'll now draw the negation of negation P. The negation of negation P. So, let us start. Negation of negation P is just the transformation of this again, taking the negation of this, and when we take the negation of f, we have what? Truth. When we take the negation of t, we have what? F. That's the negation of negation P. Okay, double negation. That is, it gives us back our original values of P. Then we have the last one, which is then this P implying negation of negation P. What does that mean? We take the value of P, which is this, and combine it with the value of what? Negation P. That is, we are looking at the two of them. Okay, if we have t, our answer is what? Is t, right? Then when we have f, our answer also is what? Is t. Okay, in the construction of implying, or what we call biconditional connective, we have that P is true when the two values of P are the same. So if we have t and t, it is true. When we have f and f, it is also what? True. So at this point we have what? T and t, which is what? Tautology. Remember I told us that tautology takes place when the values of its constituent statements are all what? True. Now we have here, this is true and this is true. So at this point we'll call this truth table tautology. Okay, so that's how tautology works. Let's now look at the contradiction table. Contradiction. Okay, He said verify the following statement by construction of truth table. Then we have the statement to be P and Q, and negation of P and Q is a contradiction, otherwise read as P intersection Q intersection negation of P intersection Q is a contradiction. Okay, the first thing we need to do is to realize that we have two elements here, which are P and what? Q, and that will make us have T, T, F, F, and for this we have T, F, T, F. You remember? Okay, what's the next thing we need to find? Then we need to find the negation of P because of this stuff here. Negation of P. For P, this is T, therefore here is F. This is T, here also is F. This is F, here becomes T. This is F, here becomes T. That's negation of what? P. And then the next thing we need to find is P intersection Q. P intersection Q. P intersection Q. That is what? P and Q. P and Q. And P and Q is only true when all the values are true. So we have truth to be T plus T. If we have T plus F is equal to F. If we have F plus T is equal to F. If we have F plus F is equal to F. So it's only true when we have what? Two truths. Okay, so we have P intersection Q. This is P, this is Q. P intersection Q, we have T, T. So here is what? Is T. This is T, this is F, we have F. This is F, this is T, we have F. This is F, this is F, we also have what? F. Okay, the next thing then is to find the negation of P intersection Q. Negation of P intersection Q. Negation of P intersection Q. That means this and this, the combination of these two colons. Okay, so this is T, this is F. Remember, it's intersection. Since it's intersection, the same law we use here is applicable here. So TF will give us what? F. FF will give us F. TT will give us what? T. And FT will give us what? F. We have FFT, F. Then lastly, we then have to plot this generally, which is P intersection Q intersection negation of P intersection Q. Okay, so how do we obtain this? This is P intersection Q, which is this. Then combined with negation of P intersection Q. So we are dealing with these two. Okay, so we have intersection. Since it's intersection, this law is also what? Applicable. It's only true when we have what? Two T's. So this is T, this is F, so we have F. This is F, this is F, we have F. This is F, this is T, we have F. This is F, this is F, we have what? F. So looking at this, we have what we call contradiction, because all the final answers are what? F, 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 and F. So since there is no T, we say that contradiction has taken place. Do we understand? So whenever you see anything like this, then it is contradiction. Assuming we have one T here, then it is no longer what? Contradiction. Okay, so let us go over to what we call the chain rule. The chain rule. It said the chain rule states that if X, Y, and Z are statements such that X implies Y and Y implies Z, then X implies Z. Let me take it again. If X implies Y and Y implies Z, then X is equal to Z. For instance, if we say that 2X is equal to let's say 4x, then is equal to, let's say, X. Now it means that this is equal to this and this also is equal to this. So we can comfortably say that 2x is equal to X. Is it not true? If we say that the equation here is equal to this and is equal to this, it means that the three of them are equal and therefore we can just come to conclusion that 2x is equal to x. Do we understand? That is exactly what we are saying here. So if we have x to imply y and have y to imply z, so simply it means that x is equal to z. Okay, so let us take an example to illustrate that. He said, in the following argument, determine whether or not the conclusion necessarily follows from the given premises. The first premise, we said all drivers are careful. That's the first premise. The second premise, careful people are patient. Then in conclusion, he said, therefore all drivers are patient. He said the first one, that all drivers are what? Are careful. And then careful people are patient. Remember, drivers here are careful. So careful people that are being talked about here is also what? The drivers. Is that true? Careful people are the drivers, since drivers are careful. Careful people are the drivers. So we can just go to the conclusion that careful people are patient, and the careful people who are patient are the drivers. So drivers are what? Are patient. So looking at that now, okay, let us take D to be people who are drivers, and take C to be careful people, and then take P to be people who are patient. People who are patient. So D is for drivers, C is for careful people, P is for what? Patient people. Looking at these premises, we can simply say that D is equal to C, because drivers are what? Careful. Is that correct? And then we can say that C also implies what? P, because we are told that careful people are patient. So if D is equal to C and C is equal to P, it means that D implies what? P. It means that D is equal to P. Do you understand? And this is what we call what? The chain rule. Chain rule. If D implies C and C implies P, then D is equal to P. Do we understand? That is what chain rule states. That is what it connotes. So, to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far, we've been able to deal with tautology and contradiction, and we've actually covered chain rule too. So we'll stop here today. Do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave a comment or question on the comment section. Till we meet again in our next class, stay safe and bye.